Now we're going to do optimization problems. I want to warn you, optimization problems take a lot of space. Kid you not, I'm doing them on this great big paper and I'm only getting one per page. Just make sure you leave yourself plenty of room and don't get frustrated. Optimization problems they're a classic business application of calculus. Suppose I'm making, I don't know, cornflakes, and I want to put my breakfast cereal in a box, and apparently in this case they don't have lids. And I want to put as much product in a box, but I want to spend as little money on packaging. So I'm going to want my surface area to be minimized or my surface area to be fixed. Which one of these containers with the same surface area will hold the most volume? And it turns out that it's not the tall skinny one or the short fat one, but indeed it's kind of the one in the middle so far as sizes go. Now, as long as you have a limited number of choices, you can use algebra, finding the length times width times height, but we're going to use calculus. Two main surface area problems. One is the box and one is a can. With the box, first of all, you need to figure out whether you're going to have to include the lids or not. The surface area is going to be the area of each side. So let's just say we have some length, width, and height. Then the surface area is going to be twice the length times the height. That's going to be this front and back side. Plus 2 times width times height, this side. And then the tops. Now, pay attention to your pictures or your diagrams because sometimes you include the top, sometimes you don't. The volume, however, is fixed. It's length times width times height. For the can, the area is, you have to take out the area of the side. Now imagine you just cut the can and rolled it out. If I have a circle R here, I have a circular top, then the area of the side is going to be 2 pi r, the circumference, times the height. And then you can add the tops if necessary, which are pi r squared. And of course the volume is the area of the base times the height, which is pi r squared times the height. Now, here are some general rules and guides for solving these problems. The first thing you need to do is identify everything given and make sure you're very clear on identifying what you're doing and make a sketch, much like I always do. Now you want to write a primary equation. Now the primary equation is one that's going to be maximized or minimized, so this is when you're going to be taking the derivative of. This tends to actually be fairly simple. It gets more complicated when we throw in our secondary equations. Usually you will have some sort of secondary equation that relates the independent variables, and you're basically going to find your secondary equation and solve it for one of your variables to plug back into your primary equation. That way you have one equation and one unknown, so you can take your derivative with just one variable. And then you're going to find the feasible domain. Now, for the most part, your x value is going to have to be positive. Make sure you check the endpoints of your equations as well. All right, let's just get to it. I'm going to maximize a box, and this does not have a lid. And I want the surface area to be exactly 108 inches. All right, so let's look at the surface area. Let's look at the volume. What is the volume? Well, it's going to be length times width times height, so that's going to be x squared times the height. Now, what is the surface area? The surface area is the area of the base. This does have a base. It does not have a top. So that's x squared plus the area of the 4 sides. Now, each of the 4 sides, it's going to be 4 times xh. And I want this to be 108 inches. Exactly. Well, I've got my primary equation. I have my secondary equation. So I'm going to solve my secondary equation. I can do this for, let's solve it for h, because I want to take my derivative with respect to x. So h is going to be 108 divided by x squared, 108 minus x squared divided by 4x, right? having a little bit of trouble there. Sorry, it's early in the morning. Let me get rid of this. Let me just do that again. H is 108 minus x squared, okay, divided by 4x. Check your algebra, folks. All right, now I'm going to plug this back into the volume equation. So I'm going to take this and put it in my volume equation. So my volume equation is x squared times h, which is 108, minus x squared, divided by 4x. Now I'm going to simplify this. X squared times 108 is 108x squared. Divide that by 4x, and I've got 27x minus x to the fourth divided by 4x is minus x cubed over 4. Now, let's look at a reasonable domain. X must be positive. All right, that's kind of a given. So I'm going to come over here and write my domain. All right, I know x has to be positive. Now, suppose x is equal to 0. All right, so if my, let's suppose the area of the base takes up everything. So the height is 0. So if the height is 0, that tells me that x squared can be at most 108. So the domain for this, I'm going to square root both sides, is between 0 and the square root of 108. All right, now the square root of 108 is about 10.39. So these are going to be my endpoints. All right, now let's take a derivative. We want to maximize the volume, so let's find where the first derivative is 0. The first derivative of this is 27 minus 3x squared over 4. Now we want to set this equal to 0. Oh, what a mess! We are going to solve this for x squared. So that's 27 times 4 divided by 3. So that's 36. So this is a max or a min when x is plus or minus 6. Now you need to write this, even though you know x cannot equal negative 6 because it's outside the domain. Yes, I want you to write it. Now you need to evaluate your volume at your 3 points, at x is plus 6, 0, and the square root of 108 at all your critical points and at your endpoints. So let's look at my x values. Let's look at x equals 6. All right. What is my volume? Well, the volume is going to be, let's go back to my volume equation right here. This is the one I'm using right here. I'm not going to even find h until I don't have to find h until I figure out which all of my volumes are. All right, so this volume is going to be 27 times 6 minus 6 cubed over 4. So at x equals 6, my volume is 108. Now, let's look at x equals 0. At x equals 0, the volume is, 0, that's easy. All right, when x is the square root of 108, the volume, and this is going to take a little bit more work, it's 27 times the square root of 108 minus the square root of 108 cubed divided by 4. And lo and behold, it turns out this one's 0 as well. Sorry. So this then is a maximum. You have 0 volume when x is 0 or when x is square root of 108. And that kind of makes sense because it's, really thin. So this is a maximum. And that's what we were doing. We were trying to maximize the volume. So if x is 6, now let's find what h is. H then is 108 minus 6 squared divided by 4 times 6, or 3. All right, so what's my answer here? The volume then is the volume is 108. 108. Let's try again. 108, and everything is in inches, so this is inches cubed. The X is 6 inches. H is 3 inches. And if I had asked for the dimensions, you'd give it to me like this. The dimensions are 6 by 6 by 3. Now I just wanted to maximize the volume. So that would have been finding this. All right, your turn. Turn off the tape when you're done and finish your homework.